Hi, I am Yuhao from City University of Hong Kong. In this video, I will tell you about our latest work on diffusion-based low-level tasks. The paper name is Diff-Plugin, Revitalizing Details for Diffusion-based Low-Level Tasks. This is a joint work with Zhanghan, Fang, Cherry and Rinson. First, let me briefly introduce the target of this paper. We hope to build a new framework. It can perform any user-selected low-level task by using a flexible language description as guidance. For example, in this figure, we show that with task-specific wording in the text prompt, our Diff-Plugin can handle multiple single tasks, such as low-light enhancement, face restoration, desnowing, derang, dehazing and multitasking that jointly conducts desnowing and dehazing. We observe that when using pre-trained T2I diffusion models, such as Stable Diffusion, to generate images, providing accurate text prompts describing the target task can be quite effective. In fact, it generally handles low-level tasks well, like removing unwanted patterns. For example, in the right figure, A, I used a pre-trained Stable Diffusion model to remove the snow from the original image. Indeed, the snow is gone. However, the face appearance has also been altered, which isn't what I intended. This is because the pre-trained model can only infer the task pattern from the text prompt and lacks detailed task-related knowledge. So, our insight into this problem is explicitly introducing the task-specific priors into the pre-trained diffusion model. The priors contain both the task's guidance information and the input image's spatial information. It enables us to handle different low-level tasks and maintain content fidelity. This figure shows our overall pipeline. Given an image and a text prompt during inference, we first send them to the proposed plugin selector to select a task plugin that adheres to the user-intended task. Then, we forward the input image to the chosen task plugin to extract the task-specific priors. Finally, we feed the priors to the pre-trained diffusion models for generating the target output. When the user wants to conduct multiple tasks simultaneously, they need to specify the tasks in the prompt, and our framework will select all matched task plugins and perform all tasks sequentially. The figure on the left shows the workflow for extracting a task-specific prior. Given an image, we first use encoder I to extract high-level visual features, which are then distilled via the task prompt branch and subsequently used to replace textual cues in the diffusion process. At the same time, we use another visual encoder V to extract spatial detail features and process them using a spatial complementation branch. These two features are then used in the decoder of the pre-trained model. The right figure shows the workflow of the plugin selector. We map the visual features and textual features of different task prompt branches to a unified latent space through a visual projection layer and a textual projection layer. Then, we compute the matching scores between the mapped visual features and textual features and select the plugins whose scores fulfill the requirements. We conducted extensive experiments on 8 tasks and compared our framework with a regression-based and a diffusion-based models. The results show that our Diff-Plugin is superior. We also conducted a user study to compare subjective ratings. The average ranking also shows that our framework is more preferred. We also validate the effectiveness of each component in our framework design. Please refer to the main paper for more details. We display several visual comparisons to demonstrate the superiority of our framework on the 8 tasks, such as desnowing, dehazing, deblurring, derang, face restoration, low-light enhancement, dim-warring, and highlight removal. Our Diff-Plugin also supports additional applications, such as old photo restoration, special effects generation, etc. These are more visual examples of old photo restoration. Thanks for watching this video.